I've been going through this research on sea stars, and
Yeah.
the Debunking study especially has me completely rethinking what intelligence even means.
It's a bit of a mind bender, isn't it?
It is. I mean, here's this creature. It can hunt, it can navigate, it can escape a predator.
But you look inside, and there's just no brain. Not even a simple one.
That's the part. I remember seeing a sea star at an aquarium years ago, and its tube feet were just wiggling everywhere. It looked like total chaos.
Right.
And then all at once they just synchronized and the whole animal glided away. I just assumed there was a pilot somewhere in the middle.
That's what most people think. But what we're really seeing is distributed intelligence. And today, that's what we're diving into. How do you get that kind of coordination with no commander?
Okay, so let's get into it. If there's no central processor, what are we actually looking at anatomically?
You're looking at a network. So instead of a brain, there's a nerve ring that goes around its maw.
A ring.
And from that ring, you have these radial nerve cords that run down the center of each arm. That's the entire system.
But a network still needs to make a decision. If one arm wants to go left for food and another arm wants to go right to escape something, you just get stuck, right?
You'd think so. But it uses a system that's often called winner-take-all. It's a kind of mutual inhibition.
Mutual inhibition. What does that mean in this case?
Well, imagine one arm smells food. It starts moving toward it. As it does, it sends signals through that central nerve ring that basically tell the other arms to quiet down.
So it inhibits them.
Exactly. The arm that has the strongest stimulus, the smell of the clam, for example, its signal essentially overpowers the others.
So the front of the sea star is just whichever arm is shouting the loudest.
That's a perfect way to put it. The other arms just sort of feel that physical pull and they fall in line.
That is just, it's incredible. It's intelligence through physics, not just computation. And it actually reminds me of what's happening in tech right now. Well, you don't always need one giant monolithic system. Sometimes you just need lots of smaller independent agents all following the right simple rules.
That's a great connection.
And it connects perfectly to our sponsor, Embersilk. I mean, if you're in business and trying to figure out how to structure your own intelligence, like with AI training or automation, this is the same problem.
It really is.
Uncovering where those autonomous agents can make the most impact is what they do. You should really check out embersilk.com for any of your AI needs.
Absolutely. But let's get back to the biology because it gets even weirder. We know how they pick a direction, but the actual movement, those tube feet you mentioned.
The water vascular system, yeah. They're not using muscles and bones like we do.
No, they are hydraulic. They're basically little water pumps. But the Debunking team found something totally unexpected in how they control their speed.
This was the bit that blew my mind. I figured if you want to go faster, you just pump harder, you pull harder, more force, more speed.
That's the intuitive answer. But it's wrong.
So what is it?
The studies show that speed has nothing to do with how hard the feet pull. It's all about time.
Adhesion time, how long the foot sticks.
Precisely. To go faster, the tube feet just let go sooner. They shorten the time they're stuck to the ground.
And this is where it gets really smart. The researchers put a little weight on the sea star.
A backpack, yeah.
To see how it would adapt. And it didn't decide to pull harder.
No, it just automatically. Each foot held on for a little bit longer.
It traded speed for grip without thinking about it.
Right. That's what we call embodied intelligence. The body itself solves the problem. The physics of the situation does the thinking before the nerves even have to get involved.
It's a huge insight for robotics, isn't it?
Oh, it's massive. Instead of building robots with a supercomputer brain controlling every joint, maybe we should be building soft robotics where the body is smart.
Where the sensors and the motors are one and the same, handling things locally.
And it's more resilient, too. A sea star loses an arm, the other four just keep voting, and it keeps going. Your computer loses its processor.
It's a brick, yeah. It really makes you reconsider our own definition of intelligence. We think it's this software running in our skull.
But for so many creatures, intelligence is something their whole body does.
It's a very humbling thought, but also really hopeful. It suggests we can build things and maybe even understand ourselves in a much more adaptable way.
Exactly. The future of tech might look a lot less like a calculator and a lot more like a sea star.
I love that. Well, if you enjoyed this deep dive, please make sure you subscribe to the show.
And hey, leave us a 5-star review if you can. It really does help get the word out.
Thanks for tuning in.